And this presentation is in no way intended as a medical advice, and it is only for educational purpose. Firstly, we come to the thick smear. Actually, why do we do thick and thin smears in malaria? Thick smear, we get a large number of parasite load. Because the smear is thick, there will be a large number of RBCs and naturally more parasites. And so this is intended to see if there is malarial parasite in the smear or in blood. And the thin smear we use to identify the species of the bacteria. Anyway, coming to this slide, what you see in this slide is a brownish pigment. That is actually the malarial pigment, also known as hemozoin. It is actually a pigment produced due to the digestion of RBCs, destruction and digestion of RBC products by the malarial parasite. In this we see the ring forms. This is the ring form identified by the chromatin dot here, and also a ring. We can't really find absolutely perfect rings in thick smears. But in this we can quite appreciate a ring. This is the ring form. Actually, what is a ring form? Ring forms are actually early trophozoites. The earliest stage of trophozoite is actually the ring form. That is when the merozoites infects the RBC. The first stage is the ring form, that is early trophozoite. Then they go on to the amoeboid trophozoite, later matures. Anyway, now this is the schizont. Schizont, actually, this is a thick smear, but you can quite very well make out the merozoites inside the schizont. There can be about 12 to 24 merozoites in each schizont. Now we go to the thin smear. I apologize for the poor quality of this because the ring form is not quite very well seen, I guess, though it was seen very well in the microscope. Here we can actually make out the chromatin dot and a vague ring. And here we can see the polychromasia and enlarged RBCs with a trophozoite form and Schaffner's dots. So what we have to understand is when there is an infection by malarial parasite, there will be RBC destruction. And when there is RBC destruction, there will be more increased production in the bone marrow, and naturally there will be more of polychromasia and normoblast seen in the smear. In this smear, we can see a polychromatic cell here, polychromatic RBC. And another thing about the RBC, about our infection of Vivax, is that the RBC which gets infected by the Vivax gets enlarged. Here you can see the RBC is quite larger compared to the other RBCs, uninfected RBCs. Here the infected RBC is quite larger than the uninfected RBCs. And then in this RBC we can actually see numerous tiny dots. These are known as the Schaffner's dots. And also you can see chromatin dot a little more enlarged, and also the bluish gray cytoplasm of the parasite. You can see it has increased from the ring stage to a larger enlarged form. Now, as I said, normoblast can also be seen. It just signifies the increased bone marrow production of RBCs in response to the RBC destruction by the parasite. In this, we can see the schizont. Schizont, you can very well make out the multiple number of merozoites in the schizont. There can be, as I said, 12 to 24 merozoites in each schizont. Now, this smear shows, or this field shows, both a trophozoite as well as the schizont. This is a schizont here below, and above one you can see an amoeboid, like a shapeless amoeboid form in an enlarged RBC having Schaffner's dots. This actually is a ring form here in the extreme left, which I have not really marked. and this shows a female gametocyte. Actually, it's not really necessary to identify the if it is a female or male in a smear, but just for educational purpose, I have mentioned that. And female gametocyte is also called as a macrogametocyte, and it has a round to oval cytoplasm, an eccentric chromatin dot that you can see the eccentric chromatin, pink chromatin dot you can see eccentrically, and the round to oval cytoplasm is quite evident. And you can also see the dots, Schaffner's dots. And this is the male gametocyte. In this, you can see the chromatin dot is actually more in the central part. It's a large pink to purple chromatin dot, and it is surrounded by a pale halo. It's quite difficult to understand, but still, a pale halo is evident here. And you can also see the cytoplasm around that. Now, this is actually, I got the table from Clinical Parasitology, a Practical Approach by Elizabeth A. Ziebeck. This shows the various stages at a glance, and you can really read it out yourselves. And this also is a picture that I got from the internet. The source I have provided below. Even though in the source is written the source is unknown, but it's quite useful to understand the morphology of the various forms. You can see the early trophozoite or ring form. You can see the developing trophozoite. Then you can see the immature schizont going on to mature schizont, which almost fills the RBCs. And go. This shows the 5 shows a microgametocyte. You can see the central chromatin dot halo, and this shows eccentric nucleus, eccentric chromatin dot in a female or macrogametocyte. Male is also called microgametocyte. Okay, thank you.